Imagine standing on a windswept beach. You feel the cool breeze, the warmth of the sun, the rough sand beneath your feet, and the cold water at your toes. Since ancient times, humans have tried to make sense of this variety. Early Indian philosophers spoke of the Panch Tatva: air, earth, fire, sky, and water. Today, science gives us a simpler, more powerful name for all of it: matter. If it has mass and occupies space, it is matter. But what is matter actually made of? Is it a solid block, or is it made of trillions of tiny, invisible Lego bricks? Matter isn't a solid sheet, it's a collection of incredibly tiny particles. To understand how tiny, think of a single drop of water. That one tiny drop contains about 10 to the power of 21 particles. They are so small that even the most powerful microscopes struggle to see them. These particles are never still. They are in a constant, invisible dance characterized by 3 secrets. Number 1, the space between. When you stir sugar into water, it doesn't just disappear. The sugar crystals break into particles that hide in the empty spaces between the water particles. Number 2, the sizzling aroma. Why can you smell hot food from across the room, but you have to get close to cold food? This is diffusion. As particles heat up, they gain kinetic energy. The hotter they are, the faster they move and mix with the air to reach your nose. Number 3, the invisible glue. Why is it easy to cut through water with your hand, but impossible to cut through a wooden table? It's because particles attract each other. In a solid, this glue is like steel. In a liquid, it's weaker, and in a gas, the particles are almost independent. We categorize matter based on how these particles are arranged. Think of an iron rod or a needle. These are solids. Their particles are packed like soldiers in a tight, immovable formation. They have a definite shape, distinct boundaries, and fixed volumes. They are rigid. Even if you apply force, they resist changing shape. They have negligible compressibility. You can't squeeze a solid into a smaller space. Now, imagine those particle soldiers breaking formation and sliding past one another. This is the liquid state. Liquids have no fixed shape but do have a fixed volume. They take the shape of their container. Because they flow, we call them fluids. In liquids, the space between particles is greater, allowing them to move freely. This is why oxygen can diffuse into water, allowing aquatic life to breathe. Finally, imagine those particles completely breaking free, zooming around like tiny rockets. This is the gaseous state. Gases are highly compressible. This is how we can squeeze massive amounts of cooking gas into an LPG cylinder or oxygen into hospital tanks. Gas particles hit the walls of their container with immense force, which is what creates pressure. Can we force matter to change its state? Absolutely. We just need to manipulate temperature and pressure. When you heat ice, you are giving its particles a boost of energy. At the melting point, the particles vibrate so hard they break free from their fixed spots. Here's a secret. While ice is melting, the temperature doesn't go up at all, even though you're still heating it. This is latent heat. It's hidden. Energy used specifically to unlock the bonds between particles rather than raising the temperature. There is also a shortcut called sublimation. Some substances, like camphor or dry ice, skip the liquid phase entirely, turning from a solid straight into a glowing gas. You don't always need to boil water to turn it into vapor. Think of wet clothes drying in the sun. This is evaporation. It's a surface phenomenon. Particles at the very top of a liquid have a bit more energy than those below. They use that energy to break away into the air. Why it cools? To escape, these surface particles steal energy from their surroundings. This loss of energy makes the surface cooler. This is why we sweat to stay cool, and why water stays chilled in an earthen pot. The pot sweats, and that evaporation draws heat away from the water inside. Conclusion: what we have learned. Before we wrap up, let's quickly summarize the core pillars of this chapter. If you're preparing for your exams, these are your must-know points. 1. Everything is matter. Matter is made up of tiny particles that occupy space and have mass. 2. The particle nature. These particles are in a state of continuous motion, have spaces between them, and attract each other. 3. 3 states. Matter exists as solids with fixed shape and volume, liquids with fixed volume but no fixed shape, and gases with no fixed shape or volume. 4. Energy and temperature. Increasing temperature increases the kinetic energy of particles, leading to changes in state like melting or boiling. 5. Hidden energy. Latent heat is the energy absorbed during a change of state that does not change the temperature of the substance. 6. Cooling by evaporation. Evaporation is a surface phenomenon that removes heat from the surroundings, providing a cooling effect. From the air in a balloon to the iron in a bridge, everything is a result of particles interacting. By understanding these tiny Lego bricks, we learn to master the world around us. Stay curious and let the science explain the rest.